Today, we're diving into the building blocks of tomorrow. And I'm not talking about regular materials. I'm talking about substances so advanced they feel like they're straight out of science fiction, but they're very, very real and they're already changing our world. So let's get right into it. So let me ask you something. What if your tablet, with its super powerful processor and beautiful screen, could just roll up like a newspaper? You could just slide it right into your pocket. Sounds kind of impossible, doesn't it? But what if I told you that's just the beginning? Well, that's exactly the promise of what we call advanced functional materials. We are talking about substances that are engineered to have what you could almost call superpowers. They can sense things, they can react, they can even change their own shape. They're revolutionizing everything from our gadgets to our health. And we're going to start with a true superstar in this field.
All right, first up, graphene. Now, you've probably heard the names thrown around, but the story of how this one atom-thick wonder was discovered is almost as mind-blowing as what it can actually do. You know, this stuff is so revolutionary, its discoverers, Andrei Geim and Konstantin Novoselov, snagged the Nobel Prize in Physics for it. But here's the kicker, the truly amazing part of the story. It wasn't found in some fancy billion-dollar lab with a giant machine. Nope. It was found with a roll of Scotch tape. I'm not kidding. They literally took a block of graphite, yeah, the same stuff that's in your pencil lead, and they just used regular office tape to peel off layer after layer after layer until they were left with something impossibly thin, a sheet that was just a single atom thick. And that is graphene.
So what is it? Well, if you could zoom in to an unbelievable degree, you'd see this, a perfect two-dimensional honeycomb made of carbon atoms. And this elegant, almost ridiculously simple structure, that's the secret sauce. That's what gives it these almost mythical properties. All right, so how strong are we talking? Graphene has a tensile strength of 130 gigapascals. Now, I know what you're thinking. What on earth does that even mean? It's just a ridiculously huge number. So let me put it into perspective for you.
Okay, this is where your jaw might hit the floor. Graphene is more than 300 times stronger than steel. But at the same time, it is so unbelievably light that a sheet of it large enough to cover an entire football field would weigh less than a single gram. And as if that's not enough, it conducts electricity better than copper. This material doesn't just break the rules, it completely rewrites the rulebook. Okay, so we've covered the strongest material known to humanity, but what about the smartest? Let's switch gears and talk about materials that can actually, well, that can remember. Meet the shapeshifters. This is a shape memory alloy, or SMA for short, and it is exactly as cool as it sounds. It's a type of metal that you can bend, twist, crumple, completely deform it. But then, with just a little bit of heat, it magically snaps right back to a pre-programmed shape that it remembers. The whole process is just fascinating to watch. You take the alloy in its original shape, you cool it down, and then you can basically tie it into a knot if you want. But the moment you apply heat, pop. It just springs right back to its original state. So the big question is, how in the world does it do that? Well, the magic is all happening at the atomic level. See, at low temperatures, the alloy's crystal structure is in this really flexible phase called martensite. You can think of it as its chill, easygoing state. But when you heat it up, the atoms rearrange themselves into a much more rigid, stable phase called austenite, which is basically its memorized blueprint, forcing the entire piece of metal back into its original shape. Now, these alloys, they actually have two pretty cool tricks up their sleeve. The first is that shape memory effect we just talked about, which needs heat to work. But the second is something called superelasticity. At a slightly higher temperature, you can stretch these things like a rubber band to incredible lengths, and they'll just bounce right back on their own. No heat needed at all. And the rock star of this whole world is a material called nitinol, which is an alloy of nickel and titanium. It's perfect for things like medical stents. Doctors can compress a stent down, guide it into a blocked artery, and then just your own body heat is enough to make it expand into its full, life-saving shape. Pretty incredible, right? All right, so we've got super strong materials and materials with a memory. What's next? How about materials that can literally generate power from pressure? Welcome to the world of power crystals and the incredibly smart sensors that they make possible. It's called the piezoelectric effect, and it's one of those ideas that's both super simple and totally profound. When you squeeze certain crystals like quartz, they generate an electric voltage. That's it. In short, pressure becomes power.
It really is just that simple. You apply pressure, which squishes the crystal's structure and separates its positive and negative charges. That separation creates a voltage you can measure. If you've ever used one of those barbecue lighters that makes a loud click, that little spark you see, that's pure piezoelectricity in action. But here's where it gets even cooler. It works backwards too. If you apply an electric current to the crystal, it physically vibrates at an extremely precise frequency. This is exactly how a quartz watch works. The tiny battery makes the crystal oscillate, and that's what keeps perfect, unwavering time. But, keeping time is really just the tip of the iceberg. This same principle is the engine behind some incredibly sophisticated life-saving tech, like the ampermetric biosensors that millions of people use every single day to monitor their blood glucose. So, how does that work? It's actually a brilliant little chain reaction. The glucose in a drop of blood reacts with an enzyme on the test strip. That reaction creates another chemical, which then hits an electrode and releases a bunch of electrons. The device simply measures the flow of those electrons, that electrical current, and translates it into a precise glucose reading. It's basically turning chemistry into a clear, life-saving number.
So let's zoom out for a second. When you take the impossible strengths of graphene and you combine it with the bizarre memory of these shapeshifters and the intelligence of smart sensors, what does our future actually start to look like?
I mean, the applications are just staggering. With graphene, we're talking about roll-up tablets, faster computers, maybe even batteries woven directly into our clothes. Shape memory alloys are giving us those self-adjusting medical implants and even adaptive airplane wings. And piezoelectric materials are enabling self-powered sensors and advanced medical diagnostics. This isn't some far-off sci-fi dream. This stuff is being built right now. At the end of the day, this whole revolution in materials science, it's about more than just making things stronger or faster. It's about making our world more responsive, more efficient, and more intelligent. And it leaves us with one massive, exciting question to think about. As we keep designing brand new materials, atom by atom, what incredible problem will the next one solve?